Hi, today in this video we'll talk about coefficient of correlation for bivariate frequency distributions. We have already seen in our previous videos what exactly is a coefficient of correlation, how to compute coefficient of correlation. Today we'll be talking about how to find coefficient of correlation for bivariate frequency distribution. So let us see what exactly is a bivariate frequency distribution. First of all, when we are saying bivariate, we are simply saying two variables, right? So what we are trying to say is when we are saying bivariate frequency distribution, let us suppose we have two variables, x and y. Let us represent x in rows and y in columns. So let's suppose x attain values x1, x2, x3 till xn and y attain values y1, y2 till ym. Here please see n and m can be same also, it can be different also. Okay. Now for here let us suppose that what is the frequency that x attains the value x1 and y attains the value y1, that is represented by f11. Frequency that x attains the value x1 and y attains the value y2 is represented by f12. Similarly, what frequency that x attains the value x2 and y attains the value y1 is f21. Frequency that x attains the value x3 and y attains the value ym will be f3m and so on. So such a kind of a distribution or table is known as bivariate frequency distribution. So today we'll particularly talk about how to find coefficient of correlation for this kind of a data. So let's see how we'll actually do it. So for this, we'll directly move into the question and understand how it is actually done, right? See, let us suppose we are given a data such that the frequencies are represented over here like 10, 3, 4, 7, 5, 6, 2, 4, 9 and x's are represented in rows, y's are represented in column. So what we are saying is frequency that x lies between 0 to 5 and y lies between 30 to 50 is 10, right? Frequency that x lies between 5 to 10 and y lies between 30 to 50 is 3. Frequency that x lies between 10 to 15 and y lies between 70 to 90 is 9, right? So this is how we see this table or distribution. Now we need to find coefficient of correlation for this. First of all, let us see what is the basic formula to find coefficient of correlation, that is represented by R. This is equal to n into summation f u v minus summation f u into summation fv upon square root of n summation fu square minus summation fu square into n summation fv square minus summation fv square, right? Now what does n represent here? N represents summation f. So this is the basic formula. I've just written it down that we've already seen in our previous videos. What is u over here? U over here is simply x minus a upon h, right? And v over here is y minus b upon k, right? So let us discuss this first. Why are we using this u and v? So see, u is equal to x minus a upon h. What is a? A is assumed mean. This is not the actual mean. This is the assumed mean for x, right? And what is h? H is just a magnitude. Why are we doing it? We are simply doing it in order to reduce the size of the figures. When we are subtracting it with assumed means, right? We are bringing the values shorter, right? But when we are just dividing it by h, we are reducing the magnitude so that, you know, the figures turn out to be in single digits or 2 digits instead of very big numbers. Why do we do this? We generally do this to make our calculations easier. This is something we have been using in finding all the, in finding all the information in our previous videos also, like standard deviation, variances, everything requires this u and v just to reduce the calculation size, right? So similarly for v is equal to y minus b, b is equal to assumed mean for y, right? And k is again a magnitude, that is simply reducing the size, that is simply reducing the magnitude of this data, right? Okay. So this is something u and b we have already been doing in computing all the statistical measures till now, right? So this is exactly the same. Now, let us see how to find the coefficient of correlation for this. We'll directly move on to question solving in order to understand it. Okay. So, yeah. Here. First of all, we have the class intervals for x and y that I've already written down over here. 0 to 5, 5 to 10, 10 to 15, and 30 to 50, 50 to 70, and 70 to 90. So the first step that we need to do is we need to write down the mid values for x and mid values for y, right? Because it's an interval. We cannot obviously work with the interval. We need to find x1, x2, x3, and y1, y2, y3. So mid value for x will become from 0 to 5, it becomes 2.5. 5 to 10, it becomes 7.5. And 10 to 15 becomes 12.5. Similarly, mid values of y, for 30 to 50, it becomes 40. For 50 to 70, it becomes 60. And for 70 to 90, it becomes 80. Next step will be, let us write down the frequencies. That is these frequencies, 10, 3, 4, 6, 5, 7, 2, 4, 9. Right? So this is 10, 3, 4, 6, 5, 7, 2, 4, 9. So this is the data, right? I've just copied it down over here, right? Okay. Next step, in order to use this formula, first of all, let's see what all things do we need. The first thing we need to calculate is u and v, right? Okay, so I'm just writing on what all things we need. We need a u, we need a v. What else do we need from here? We need fu. So we need fu, then we need is fv, then we need is fu square, then we need is fv square, and the last thing we need is fuv. We need to find all this data, right? Okay. So the first step we'll do is we'll start by finding u, right? U is for x. So u is equal to x minus a. What do you think a should be? Can we say from these values 2.5, 7.5, 12.5, it will be most easiest to take a as 7.5, right? Because 2.5 minus 7.5 will become minus 5. 7.5 minus 7.5 becomes 0, and 12.5 minus 12.5 will become 5, right? Also, after considering these a, after subtracting this a, we are getting all the values in the magnitude of 5. Minus 5, 0, 5, right? See, 2.5 minus 7.5, this is equal to minus 5. Similarly, 7.5 minus 7.5 is equal to 0. And 12.5 minus 7.5 is equal to 5. So this is after we are simply subtracting the assumed mean, that is a, right? So we can use 7.5 as assumed mean upon, what do you think should be our h? Our h, that is number we are dividing, it should be 5 so that we get the figures in minus 1, 0 and 1, right? It's not always necessary to get the figures minus 1, 0, 1. It's not always necessary, but we are simply trying to reduce the magnitude as far as possible in order to make our calculations as easy as possible, right? Now, 2.5 minus 7.5 upon 5 will become minus 5 upon 5, that is minus 1. 7.5 upon minus 7.5 will become 0. Divided by 5 will become 0. 12.5 minus 7.5 is 5. Divided by 5 will again become 1. So these are our u's. Now we'll talk about v. V is equal to y minus. From here, can we say this is 40, 60, 80? What do you think? What should be our b? V is equal to y minus b upon k na. So what do you think? What should be a b? Can we say it will be easiest to take b as 60 because the values will become 0, minus 20 and 20, right? Now 40 minus 60 will be minus 20. 60 minus 60 will be again 0. Then 80 minus 60 will be 20. So what do you think? What should be our k over here now? Assume mean is 60, right? So k should be 20. How? Because that will again make these in a figures of minus 1 and 1. So y minus 60 upon k, that is 20, right? So this becomes 40 minus 60 upon 20 becomes minus 1. 60 minus 60 is 0. 80 minus 60 is 20 upon 20, that again becomes 1. Now this u and v have taken the smallest and the simplest figure that will ease our calculations. Okay. After this, what we need to find next? We have figured out u, we have figured out v. Next we need to find is fu, right? So fu, how will we find it out? First of all, before fu, we need f. That is marginal frequencies. When I am saying marginal frequencies, I am simply saying, let's suppose marginal frequency for x. We are simply saying, irrespective of what the value y takes, what will be the frequency of x lying between 0 to 5? So this is the marginal frequencies. If I'm writing over here marginal frequency for x, I'm simply saying irrespective of what the value y takes, what is the frequency that x will lie between 0 to 5, right? Similarly, if I'm writing marginal frequencies over here, so it's for a particular class interval 30 to 50. So we are saying irrespective of what the value x takes, what is the frequency that y lies between 30 to 50. So we need to find these f's. So in this question, it's very simplified. We are already given these f's, but it might not be given to you in the question. So we'll just simply see how we're adding it up. We will add this up. So irrespective of what the value y takes, what is the frequency that x lies between 0 to 5. So we'll consider all the cases of y's for this particular class interval of 0 to 5. So this is 10 plus 6 plus 2. This becomes 18, right? Then 3 plus 5 plus 4 becomes 12. Now for 10 to 15, irrespective of what y takes, what is the frequency of x lying between 10 to 15 is 4 plus 7 plus 9, that is 20. Okay. Now here, this f. So when we are saying marginal frequency for y, we are simply saying what is the frequency of y lying between 30 to 50 irrespective of x lying between 0 to 5. We are simply saying कि क्या फ्रीक्वेंसी होगी कि y 30 to 50 के बीच में लाई करेगा, नो मैटर x की क्या वैल्यू है. x कुछ भी हो सकता है, but y should lie between 30 to 50, right? So now for that we need to add all these. 10 plus 3 plus 4 is 17. 6 plus 5 plus 7 18. अब इसके अंदर 70 to 90 में हम कह रहे हैं x कुछ भी वैल्यू ले, क्या फ्रीक्वेंसी होगी that y lies between 70 to 90. So this becomes 50. 2 plus 4 plus 9 is 50. Okay. Next, what do we need? We have to find out fu, right? Okay, so let's find out fu. Okay, so fu is simply f multiplied by u. So these are again marginal thing, right? Because it's all marginal fus. So this is f into u. So this is f and this is, sorry, we'll write it down over here as fv because these are the column thing, and over here we'll write down fu. So when we are saying fv, we need to simply multiply f by v. So we are saying irrespective of what the value x takes, we need to multiply v with the frequencies of f, that will give us fv. So this is minus 1 into 17 is minus 17. 18 into 0 is 18. 15 into 1 is 15. Right? Okay. Now fu is irrespective of what y takes. What is the fu for class interval 0 to 5? So that is this. This is our u now. So minus 1 into 18 is minus 18. 12 into 0 is 0. Then 20 into 1 is 20. What else do we need to find? We have figured out u, we have figured out v, fu and fv. Next is fu square. So fu square. Why are we writing fu squares in column form? See, simply because we have f over here and u is also parallel to it. We need to compute these values parallel to the values of x. And for v's, we need to find the values parallel to the values of y. Okay, so fu square, and over here we will find fv square. So fu square simply means f, that is this column, multiplied by this u into u. So u square into fu, or you can also think it as like this fu multiplied by u. Right? We are simply saying if to find fu square, we can multiply fu into u. Right? So this becomes fu into u means minus 1 into minus 18 becomes 18. 0 into 0 becomes 0. 20 into 1 becomes 20. Right? Similarly, for fv square, all we need to do is we need to multiply this fv with another v. So this becomes minus 17 into minus 1, that is 17. 0 into 0 becomes 0, and 15 into 1 becomes 15. So this is fv square and fu square. We are already done with it. Next is fuv. So now fuv is a tricky thing. Listen to it very carefully. All we need to do is we need to make small boxes here like this. These boxes, please see these boxes. Where am I making these boxes? I am making these boxes at the same place where we have written the frequencies, to the top right corner. Right? So now this fuv will be subject to u's and v's and f. So we are saying for a particular u and a particular v, we are finding a fuv. Right? So we obviously need to find it somewhere. Right? So we are saying is fuv means multiplying, let's suppose, first of all this multiplied by this multiplied by this. For this particular combination of 0 to 5 x and y as 30 to 50, we need to multiply these three. So this becomes 10 into minus 1 into minus 1 becomes 10. For this interval where x lies between 0 to 5 and y lies between 50 to 70, for this particular combination, our fu will be 6 multiplied by minus 1 multiplied by 0, that is 0. For this particular combination where x lies between 0 to 5 and y lies between 70 to 90, our fu will be 2 multiplied by minus 1 multiplied by 1. So this becomes minus 2. Similarly, for this particular combination, 3 multiplied by 0 multiplied by minus 1 is 0. 5 multiplied by 0 becomes 0. 4 multiplied by 0 multiplied by 1 becomes 0. For this particular combination where x lies between 10 to 15 and y lies between 30 to 50, this will be 4 into 1 into minus 1. This becomes minus 4. 7 into 1 into 0 becomes 0. 9 into 1 becomes 9. So these are FUVs for a particular combination of UV. But what do we need actually? We need FUV in terms of marginals. As in, let's suppose, irrespective of what value, irrespective of what value U takes, we need to find FUV for a particular V, that is minus 1, or for a particular class interval 30 to 50. How will I find it? We will simply add 10, 0 and minus 4. Right? So this becomes 6. Adding this up becomes 0. Minus 2 plus 9 becomes 7. Now again we will find FUV over here. So over here we are saying irrespective of what the V is, what will be FUV for a particular class interval 0 to 5 or for a particular U minus 1. So this becomes 10 plus 0 minus 2. We are just summing it up. Na? 10 plus 0 minus 2 becomes 8. 0 plus 0 plus 0 becomes 0. And minus 4 plus 9 becomes 5. Right? So we have computed FUV also. Now from here we can see that all we need to do these in terms of summations. So what will we do? We'll simply sum this all up. Right? Okay. So let's just sum everything up. So summation F we will get from here, right? And from, So we can just sum this up from either way. 18 plus 12 plus 20 will be 50. Similarly, 17 plus 18 plus 15 will also be 50. So this will always remain same. Since it's the adjacent part, it will remain same. Next, what will this give us? This will give us F summation FV. This will give us summation FV square. This will give us summation FUV. Similarly, this will give us summation FU. This will give us summation FU square. And this will give us summation FUV. Now see, summation FV. So this is minus 17 plus 15. This becomes minus 2. Right? FV square is 17 plus 15. That is 32. Now FUV is 6 plus 7. That is equal to 13. From here, FUV. 8 plus 5 is equal to again 13. Now since this 13 and this 13 are same, summation FUV has to be same irrespective of from which way we are calculating, either from column or rows. It has to be same and it's same. So this tells us that our calculations are nearly correct. FU square means 18 plus 20. This will give us 38. And summation FU is minus 18 plus 20. This is equal to 2. So from here, we have already calculated all these figures, right? Now, we have already gained this information. So let us just write down this particular information over here. So we've already calculated summation F, which is equal to N, is equal to 50. Summation FU, summation is equal to, let's just write it down. Summation FU is 2. Summation FV is equal to minus 2. Summation FU square is equal to, FU square is 38. Summation FV square is equal to, from here, 32. And summation FUV is equal to, you can take the figure from either place, that is 13. Right? Now we need to simply put it in the formula, that is R is equal to N summation FUV. This is an old formula. I am not put in any other formula. This is the basic formula that we use to find coefficient of correlation. Upon square root of N into summation FU square minus summation FU square. This multiplied by again square root of N into summation FV square minus summation FV. So let's just put in the values. N is 50. 50 multiplied by FUV. FUV is 13 minus, what is summation FU? 2 multiplied by, what is summation FV? Minus 2 upon square root of N is 50 into summation FU square. 38 minus summation FU whole square. Summation FU is 2. So 2 square is 4. We'll just put it again. And this becomes N is 50 into summation FV square is 32. Minus summation FV. Summation FV is minus 2 square. Right? So here, now 50 into 13 is 650 plus 4. Right? So yeah, this becomes 15 to 38 minus 4, right, multiplied by square root of 15 to 32 minus again 4. So this simply becomes 654 upon square root of 1896 square root of 1596. So these are the calculations I've already done. So I'm just writing these down. Although in exams, in our graduation, we do get to use the calculators, but otherwise you can always calculate these. So this becomes 654 upon 1739.54. So dividing this up becomes plus 0.376. Right? So from here we can say the coefficient of correlation for this bivariate frequency distribution is 0.376. Right? So this was easier to find. This is an important question from exam point of view as well. I hope you liked this video. Do subscribe this channel for more videos. Thank you.